Welcome to the Garage Engineer. I'm Dennis. And today in the workshop we're going to disassemble this old broken microwave and talk about what parts we can salvage out of it for future projects. And possibly at the end of the video we will put together a quick and simple project that I've been needing for the paint booth. So let's get started. So this microwave died at a relative's house and I helped them replace it with a new one. Now what makes this a little bit different than typical microwaves is this was over the range, so it's going to have a motor that it was used for the exhaust. So that's another benefit. We'll get a motor out of it that we can use for future projects. Typically when these break, they just get thrown out and people buy new ones. But there's still a lot of good parts that we can use for future projects. So let's get tearing inside this one. So the first thing whenever you're tearing into any project, normally I keep the screws in a particular order so that when I'm putting it back I know the order that it came out of. But for this, when you're disassembling it, I just like to put all my parts together. I usually get a magnetic tray because having those extra little screws stored away, if you're working on a project, they might come in handy. Now the first two screws that we do have are these long threaded ones that went in the top here to hold the microwave into the top of the cabinet. So those will be the first screws we'll save. Now let's turn this microwave around. It's always a good place to start. And we'll get the cover off by unscrewing all the screws on the back. And to save time, we'll use our trusty 12-volt drill. Here's a vent cover that goes on top here. I think it's holding this in, so we'll unscrew that. Pretty much you just want to unscrew everything. The good thing about some of these screws, these are sheet metal screws, and so they're good for when you're just trying to drill two pieces of thin metal together. So screw them together. So those will be good and reusable. Now this motor, let's see if you can see here. This exhaust motor is really good. It's got two nice fans on the ends here. And it's very quiet. But what's holding this in is one, we got a couple screws. We got a screw here. And that's it. And then we've got a plug. Let's see if we can unplug it here. It's way back inside there. So what we'll do is we'll get the cover off and then we'll unplug it at that time. I see some screws on the top here and on the side, so I'm gonna go ahead and get those out. And I think there's a few screws on the bottom here that we need to get off. Yep, here we go. We need to get those off too. Okay, I think that did it. Now I did want to mention, these two had two charcoal filters that if they're not too greased up, they would make great filters if you wanted to make a benchtop filter for soldering. I didn't bring those because they were just so full of grease that I didn't want them. We do have some light bulbs down here. They might still be good, so we'll go ahead and save those. These look like they were siliconed in, the light bulbs were. They must have been done at the factory because they must have had a problem with it wiggling out. So that was kind of interesting. I'll keep this whole bottom together after we unhook the wires. And we might be able to use these lenses here for some projects if we're covering up a light or something like that. They're pretty nice piece. So we'll keep all this together. So right now we'll just undo the lights. And these are my favorite pliers we had in some of the other videos that I got a while back when we were working on one of the motors. These are vice grips, and they're the 8-inch version, which I think they're very helpful. And they can make them as big as you need them, and they fit just right in your hand. There you go. Perfect. We'll set this to the side. Now right here, let me get you in closer. So we're at the bottom here. This is what turns the Lazy Susan on the inside. Right here, that's a motor, and that is a very good one. I'm not going to save really the wiring too much. I'm going to go ahead and cut. There's another one of my favorite tools too, is a diagonal cutter. this diagonal cutter, you can get real close into where you want to cut. But we're going to go ahead and cut this. I don't think the motor really matters, a positive, negative, but I want to keep the black and the white so I know which way it goes. So now that we're at the front here, I'm going to open this up. So this was that Lazy Susan I was talking about, and this would make a great glass plate. And this is, I think, what we're going to try to use in our future project. And then here's the bottom part of the Lazy Susan. And here's that cap that goes with the motor. So we'll just kind of stick that together. This is the cap that's keyed to the motor just like that. So we'll keep all that together. Let's see if we can get this cover off. There you go. Now typically this metal is not good. Well, it is good, I should say, not good, but it is good to save, to use if you want to do a patch for a panel on another project or access port and you want to make a cover for it. So it's pretty good metal for that. Okay, so I don't normally give warnings on videos, but since we're dealing with electronics, I wanted to stop right now since we're inside the microwave. Now, this is unplugged, and that's how you should always work with anything with electronics, so we're safe on there. But the special thing about the microwaves is they've got a big capacitor inside that needs to be dissipated. Now, by unplugging it and letting it sit, which this has been sitting for a week, it should be dissipated. But if you're not sure or it just got unplugged, you need to dissipate the capacitor so that it is safe for you to handle. So I don't know, this is a little different than what I've seen before. Is this has a little either resistor, or I think this is a little resistor going from the capacitor and grounding it out to the body of the microwave. And then there's another lead there. So what I'm going to do is take a wire and ground that lead to, take that lead and ground it to the microwave base, and that should discharge it. Typically what people do is take a screwdriver and just touch the two leads, wearing gloves or something, or usually the screwdriver has a plastic cover to protect them, and they can touch it that way. Or what I like to do is take a piece of wire, and it's insulated, but I also like to hold on to the wire with pliers that have insulated handles to even be more protective. But we're just going to ground that out. And you should also always be wearing your safety glasses too, so I'll be doing that. So I think we're good, everything's grounded out. It's dissipated, so let's get this unhooked. First thing I do see I wanted to show you is the fuse here. Let's see if we can get this fuse out. That the fuse is busted on this whole thing. So this whole thing was probably fixable and just needed a new fuse, or something else shorted inside it and caused the fuse to bust. Either way, the person needed a new microwave. But there is signs of that is the problem. So if we put a new fuse in there, it probably would start working. Well, just for fun, since we think that the fuse is busted on here, I do have an extra one. I don't know if it's the exact one, but it's going to be good enough to get started. Let's try to put it in and see if we can get it working. I don't know if that got caught on the video. We'll have to go back and check it. But you did see a spark come. Here, we're going to unplug it first. Let's unplug it. You did see a spark come out of this fuse right here. So that tells me, I heard it click on and then click off. So I think there's something internally wrong with this that caused the fuse to break. So definitely needed a new one. I don't think we could have fixed it unless we would have changed the electronics out or anything. But that definitely is the cause of it. So, not fixable. Yep, there you go. The fuse is busted. So now that we plugged it in for a second, the capacitor It might have recharged. Let's go ahead and dissipate that again like we did before. We're unplugged. So we're going to get our wire here. We're going to ground it. So I think we're good. Now, one of the things that I always do when I am salvaging any electronics equipment is I like the plugs. This is a nice sturdy plug that could be reused on another tool. It is a little short for some tools, but is definitely heavy duty. Even an extension cord, if you needed a short extension cord, this would make a great one. So what we're going to do is, I like to cut it off as long as possible. So we got the ground here. Actually, I'm going to save that ground. I don't know why, but we'll save it anyway. So we'll unscrew that, and then the power plugs are over here. So let's go ahead and get that off. And there you go. So this is our another part. We got a good extension cord. We'll put that off to the side. I probably won't keep this. Has to deal with the power. I don't think there's electronics on it. You could probably salvage and desolder, but for me, I'm running out of space, so I don't have any place to put it. So we're just going to cut it, and we will see if we can recycle it or throw it away, one of the two. So at top here, this is another one of those carbon filters. This is a little cleaner. It doesn't have as much grease since it's on top, but this is definitely what you can use to make, if you want to make a fume extractor or a desktop fume extractor or something that needs a carbon filter. So definitely keep that one. And here we are. This is the plug for the fan. So now we got access to it. We can take that out. So again, this is a really great motor here. And then you've also got the blower parts. Look how smooth that is. It's quiet. It has good bearings in it. This would make a great project, so I like that. So again, here's just wire. We'll let it go, and we'll save the wire. So for projects where we need short little pieces, we can just pull it off, cut it off as needed. Right here, this is a capacitor, a microfarad. So we'll keep that. Let's use that. So here's the electronic board. These are pretty much micro-controlled for the specific project. There's not much you can get off of it. There's some capacitors if you want to desolder them, a resistor, and some more capacitors. But that's pretty much it. You could probably save the LCD screen on the front here if you had an Arduino project, a Raspberry Pi project you could use. I'm not sure about the keypads if they're reusable or not. But let's see. Well, we can get it unscrewed and take a look at it more. So there's the LCD screen you could probably reuse, and the keypad is on the inside here, so let's take a look at that if we can get to it. Here's the instructions if you needed it. How to check the capacitor, the Megatron, the transformer. Here's that capacitor we were talking about. It says measure the resistance, ohm meter scale to 1,000, but it doesn't tell you what it should read. I guess open or close, basically that's all that. It says normal is momentary, indicates several ohms, then gradually returns to infinite. So that's interesting. And here's the ventilator motor. So this is pretty useful. I've never seen this before. Here's the turntable motor too, how to check it. Oh, it tells you even how many ohms. If the motor's still good, it'll tell you how many ohms it is. I want to take a quick short break from our deconstruction to show you how you could use the instructions that was given to us about how to test the equipment. And this is pretty good for any motor. Now this motor says that to be good, it's going to have a resistance of the windings inside the motor of 3,300 ohms. So what we need to do is take your digital multimeter, and we'll set it to 20,000 ohms. This isn't auto sensing, so you gotta choose which setting you want it at. And then all you do is take the probes. Let's see if we can set this up for you so you can see. You take the ends and just touch it to the wires, and then I'll give you how much resistance you got. And so this has 3,000 ohms of resistance, so this motor is good. So this wasn't the part that was bad in the microwave. But you can do that with any testing of a motor. The good thing about this piece of paper, it tells you actually what it needs to be, because different motors have different resistance. So you kind of might have to look up what that motor's resistance is to see if it's good or not. But since we know what the manufacturer says is good for this, we know this is a good part. So let's move back to the deconstruction. I've never seen that before, and here's the schematics, so that's always good to have. So we'll go ahead and keep that. That's just kind of useful information. The keypad is integrated into the front here, so I don't know how. You'd have to really tear into this to get it, so I don't think it's anything that I could use. So we'll put this off to the side. Okay, so I'm pulling out right here, I'm not sure if you can see, is the oven sensor. It's kind of hidden back behind there. The oven temperature sensor. So we'll keep those temperature sensors. We might be able to find a project for that. There we go. And this is the temperature sensor for the microwave that we cut. I was backwards on that. So that's the sensor right there. So we'll definitely save that. And then I guess we'll save this light bulb socket. And they glued this one in too, so that must move around during package shipping. So we'll keep that together here. It's not too bad. Now we can get into some of here. This is the temperature, another temperature sensor for the magnetron. We got a screw here. Now I'm not sure what can be used on the magnetron, so I might keep it, but I'm not really sure what it can be used for, what projects. But I'm sure there's a lot of on the web, some other projects you can use it for. But then the transformer here is what people use for Lechtenberg. Now I'm not going to go into that because it can be pretty dangerous, because you're actually using electricity to burn those lightning shapes into wood. It looks pretty neat, but that's a little bit past my expertise of what I want to teach, and I don't even know if I really want to do that. But that is what, I'm sure there's plenty of websites, videos on that. And then here is the fan motor. So this is another little motor right here, definitely useful. It's very quiet too, so that's definitely something we'll keep on hand. So let's get this capacitor out now. We can get to it easier. This is HV high voltage capacitor, 0.9 microfarads. Keep that off to the side. Here's two more temperature sensors, so we'll keep those. One's for the stove underneath, and one is just for ambient temperature, I think, just to use to compare to what the ambient temperature is compared to what the other is reading. So there you go. So we'll get, right here is the door assembly. Let's see if we can get that out. And the good thing about the door assembly, it has 3 momentary switches in here, which those are definitely good for any type of a robotics project, electronics project. So let's get one of them out. There you go. See, here's a little momentary switch right here. Hear that clicking? So those are definitely, you can definitely keep that. That's pretty good. We'll get the magnetron off. So that's what causes all the vibrations in the your molecules, water molecules, and that's what heats it up. It's pretty neat. I have to do some research on that. We need to flip over and unscrew it from the bottom here. Alright, there's the wire and harnesses. There you are. Very heavy, very high voltage too. Other than that, I think that's it. The rest of it's just the carcass. So thanks for coming along on this trip with me. It's been a pleasure, and remember the ABCs of making. Always be creating. Till next time. But wait, don't click to that next video. I promised you a little project using some of these parts. Let's get into that now. So something I've been needing to take pictures and to show off some of the projects that I build. I wanted to build a Lazy Susan, but I didn't want to just be a regular Lazy Susan. I wanted one that was motorized. So what we can use is some of the parts from the turntable inside the microwave. So some of the parts here, we've got the turntable, we've got the bearings here, and then the motor. Now let's take a look to see what power this runs off of. This is a 120 volt motor, so I can't use it because I'm going to just I want to make it simple so I don't have to plug it into a wall. I just want to make this battery powered. We need a DC voltage motor. Salvaging different projects. This came off of a kid's toy. What this is actually, it's a motor in the back, but it's connected to a gear system that rotates this 90 degrees, and then the axle moves around. So what we do is, let me show you how it works. This is a battery pack, and I wanted to show you, they have some battery packs that just hold the battery in here. This is just a single A battery. But if you're ever having to buy it, make sure you get the one with the on-off switch in here. This is great that it comes with an on-off switch. So makes your projects one less thing you have to do for a project. So I connect the battery up to the motor, turn it on, and you can see we're moving right here. Now that is going to be way too fast for us moving the turntable, and I wanted to change different speeds too. So to reduce or speed up a motor, DC motor, is to add or subtract voltage. So we need to change the voltage that's being supplied out of here. So you got 1.5 volts with a AA battery, but the way we can reduce it is bam, with this piece right here. Now this old little junky thing was came out of a intercom system in a house, and what we need is this round part right here. This is called a potentiometer right here, where you turn the knob and it reduces the resistance or it increases the resistance. Now basically, if I knew exactly what speed I wanted to go at, I could just put in a resistor in line with the battery right about here, and it would set the speed, and that would be it. But if I wanted to play with it and to figure out go fast or slow depending on what project I was doing, use this potentiometer and it will speed up and slow down the motor just by turning the knob. So just to make things easier right now without soldering, I'm just going to clip the wires directly to this board. I'm not going to use anything else on the board. I just need the potentiometer. Maybe later when I make it more permanent, we will take this off, but right now we'll just leave it on just for testing purposes. The first thing we need to do is cut a base to hold our motor on the bottom side and our bearing on the top. Then we find the center of the plate, drill a hole so it will set the motor. Now we're going to take our motor stick our board over our motor. Now this piece is a little too long, so what we're going to have to do is raise the platform up, and we'll do that with 1-inch blocks to bring it up, bring the height up. I did connect a alligator clip wire to one of my motors here, and we're going to extend it out for, I'll show you in just a minute why. So what we're going to do is put our board over our motor and put a little bit of hot glue here. Stick it on our motor. That should. We'll let that cool for a little bit. While that's cooling, so we're going to take, here's our potentiometer. We're going to take one of the alligator clips going to the motor and connect it to the center there. And then the other alligator clip, the white one, we're going to connect to the other leg and connect that to power. To test it right now, because the end of this wire has one of these small connectors. I think they're called JTMs. What we're going to do is connect it directly to the battery inside. We're just going to connect it to the red wire where it connects to the battery on the inside there. That should be good. Let's test our motor to see if it's working. So it's not working now. Let's see if our connections, there you go. So as I turn this, I can shut it all the way off because there's not enough voltage, but if I turn it just a little bit, there you go. So we're going to turn that off, or turn it down. Let's put on our glass plate and see what we got. Well, there you go. A little bit of fine tuning there. Well, there you have it. That's only one project that you can make with parts from the microwave oven. If you tell me what project you could come up with in the comments below about using some of the parts from what we recovered. Again, thanks for watching, and I hope you enjoyed it, and check you out next video.